Alright, yo, so you see this strange figure, looks like a square that got beat up. That's exactly what a composite figure is. So it's basically a figure that's composed, you see that word, composed, of other shapes. Because you see here, we have a triangle over here, we have another triangle over here, we have a trapezoid over here. It's composed of other shapes that we know how to calculate the area of. So the sum of all the areas of these shapes in the composite figure is going to be the area of the total composite figure. So how are we going to go about finding the area of these shapes though? So it gives us some dimensions of this weird shape. We have 5. We know the distance from here to here is 5. We know the length from here to here is 9. We know the length from here to here is 3. We know the length from here to here is 8. And we know the length from here to here is 4. We even know from this symbol over here that this is a right angle between the two. So there's a lot that we know. So let's figure some stuff out. So first, let's calculate the area of this triangle. This triangle right here. So imagine we had a rectangle that was 3 units, or sorry, that was 4 units by 3 units. How would we calculate the area of this? We'd multiply 4 times 3 and get the area. But now we have a right triangle, which is only going to be half of this rectangle. So we only want this part. This is what we're worried about. So we can say that 1/2 times 4 times 3 will be the area of this part of the shape. So what does that equal? 1/2 times 4, cancel that, 2. 2 times 3 is 6, so the area of this will be 6, right in here, 6. So then, what else do we have? We have the same thing for this triangle too. So we can say that 1/2 times 4, because we have a 4 up here, times 8 will equal our area. So again, 1/2 times 4 is 2. 2 times 8, 16. And we have 16. So we can put a 16 in there. And now for this trapezoid, like it's an awkward looking trapezoid thing. Like we don't really know how we're gonna calculate this. But again, let's break this down once more and make 2 easier shapes, because a trapezoid is like a composite shape as well. So how do we find the area of a rectangle? Because now we've created a rectangle and a right triangle. So the area of a rectangle, we take the length, which is 5, times the width. What's the width here? So we know this part right here is 3 and this part right here is 8. But in our rectangle, we want the whole thing. So 3 plus 8 equals 11. So we can say that this side length right here would be 11. So length is 5 and width is 11. So 5 times 11, what does that equal? 55. So we have 55. And then for our last shape, we have a triangle and we have the height, but we don't have the base. But we can easily find the base because it gives us this 9 right here and it gives us this 5 right here. And there's a relationship between the two. So we can say this distance right here total is 9. But from here to here, because of this 5, we know this distance right here is 5. So 5 plus something must equal 9, and that something is obviously 4. So now we can say the base of this right triangle is 4, and we can just use our equation to find it. So for this right triangle, we have 1/2 times 4 times 11. So cancel, we have 2, and then 2 times 11, that equals 22. So this is 22. So now to find the total area of this composite figure, we can just add all the areas together. So we have a 6 from here, we have a 16 from here, we have 55, we have 22. So let's add them up. 6 plus 6 is 12, plus 5 is 17, plus 2 is 19, carry the 1. 1 plus 1 is 2, plus 5 is 7, plus 2 is 9, and we're good. That's our answer to the problem. And then, because it's area, we always want to say units squared. So 99 units squared.